going to do a quick look at scalar multiplication of vectors, and then we will be looking at how to find component vectors of full vectors. So for starters, scalar multiplication of vectors is pretty cut and dry. If I have a vector v, and I know that the components of that, I've got a for the horizontal, b for the vertical. If I multiply this by some scalar here, so in this case I'm just going to use alpha. It's just a real number. It has no direction. It's just got a quantity, a magnitude. Really, you can think of it as it's just going to distribute to both the horizontal and to the vertical. That's it. Once you've got that, then from that point you can determine the magnitude. You can add it or subtract it from another vector just as you would normally do. So let's see how that might work right here. I've got a vector v, and the components of that are 3, -2. If I distribute this 4 to v, so this is my scalar multiple right here. This is where that alpha was up here. Okay. If I've got that, all this does is make this 4 times 3. That's a 4. I know that looks slightly 9-ish. Let me correct that. And 4 times -2. 12. -8 is 4v. From here, if I want to find the magnitude, I would do it the same way that I would do for any normal vector. I would take these two quantities here and then square them, find the square root of their sum. That's it. I can add them or subtract them from here. Just remember to distribute whatever the scalar is to the component vectors, or finding component vectors. So let's say that I've got a vector w, and I know that it is 35 degrees from the horizontal and has a magnitude of 20. So first thing I'm going to think of and draw is a picture. So here's my vector, and the magnitude of this is 20. I went ahead and marked down the magnitude here. And I know that I'm 35 degrees from the horizontal. The horizontal is that dashed line that I marked in there. And I know I've got a 35-degree difference. Notice that my markings here, I'm working from a horizontal line that goes to the positive side of the x-axis, which is pretty standard when we're working with finding angles. So we've got a possibility of a total of 360 degrees. We're going to start in quadrant 1 right here, going from the positive side of the x-axis. So 35 degrees. So looking at this is kind of bringing into mind here, if I add a little bit of a vertical there, and I mark that down there, I have got a good old right triangle. And using the fact that I've got this 20 here, what part of a triangle, right triangle is this? This side where the vector is? This would be your hypotenuse. So I've got an angle, I've got a hypotenuse. Now I can solve for every other side of this right triangle. Since I've got my angle right here, that would be in that this is going to be my opposite side. And similarly, this would be my adjacent side down here. So we see that the vertical component is really going to be your opposite side, which is sine. Opposite over adjacent. So katoa, right? So if the sine of 35 degrees is equal to my opposite, and this is really what my my vertical is. Opposite over, in this case, 20. What that means, I shouldn't make an equal sign there, I should just continue separate equation. 20 times the sine of 35 is going to give us the opposite side. 11.47, going to the nearest hundredth. And really what this is 11.47. My vertical component is j. And for the horizontal, I can do the same thing. The cosine of 35 is equal to the adjacent over 20. Therefore, 20 times cosine of 35 is equal to the adjacent. That gives me 16.38 equals my adjacent side. And my component vector that I get from here, this is again the horizontal. That's the horizontal, is 16.38 I. So putting these together, I can say that my vector W is equal to 16.38 I plus 11.47 J. Again, the horizontal comes from the cosine, and the vertical comes from the sine, because you've got a right triangle. We can put this into a more generalized form of, if you have a vector v, then your horizontal component is just going to be the magnitude of v times the cosine of theta. And then the vertical component would be the magnitude of v times the sine of theta. Okay, let's practice one. Work on this in your notebook. If the magnitude of a vector w is 40, and you've got an angle theta from the horizontal of 150 degrees, find the component vectors, the I and the j. All right, work on that, bring your questions, and have a great day.